Hey everyone, good morning and welcome to today's webinar. We're going to be covering cable planning harvesting analysis using RoadEng Forest Engineer. And so should mention this is also just terrain tools forestry because we're going to be focusing pretty much exclusively within the terrain module of the program. I'm Erin. I'm going to be doing the opening today, and then I'll pass it over to Dave, who's going to be doing our live demo. Cable harvest planning and analysis can, definitely help improve both your equipment and your landing locations, as well as potentially allow you to increase your efficiency of your harvest operation. So as many of you know, we completely redid our cable harvesting components to our software in version 9. And now, especially when you're working with high-resolution digital models such as LiDAR, it does allow you to simultaneously explore multiple areas for deflection, getting some visual feedback through our plan window and color coding that we've now got on the deflection lines, as well as a whole bunch of other new features and functions that Dave's going to show you today. But before I pass it to Dave, just a couple pieces of housekeeping. First of all, please, ask us questions, engage with us through the Q&A section of your GoToWebinar panel. It likely is going to collapse during the webinar, so you just need to press the little button to expand it, and there's a spot where you can enter your questions. And we'll address those at the end. Second, this webinar is being recorded, and we will send it out as an email blaster afterwards with a link to where it is on our YouTube page. And then we've also added the certificates of attendance. We're trying a few different methods. We're trying one this week available through GoToWebinar. So you should, in your follow-up email, you should see an automated link to where you can get your certificate. If you have any questions, please let us know. And then lastly, just, continuing the message that we're delivering, I think, every week to everyone, stay healthy, stay safe, enjoy your long weekend if you're somewhere that has one. And with that, just quickly going to cover our agenda. Oops, sorry, I just zoomed in. What a fail. Our agenda for today, well, we are going to be, first of all, bringing in a LiDAR-based terrain model. Dave is going to explore different areas for deflection. And you can see in our little image here what our explore mode looks like. We're going to be analyzing payload, clearance, and line tensions, evaluating different equipment and logging configurations, plotting our carriage positions, given midspan deflection. And then finally, it wasn't included in our little blaster, but we are going to also show you how to create a quick output sheet showing some of our cable details. And with that, I am going to pass it over to Dave.
Thank you, Erin. Now I think my screen should be visible. Have I
You're all good here, Dave.
Right? You can see my 3D window.
Absolutely.
Okay, so this is a different model than I used last time. It's a little bigger. This is about 3.5 kilometers by 1.5 kilometers. It's pulled in from LiDAR data. I send it down to minimum 2 meter spacing. Some of the points are farther apart because of sparse LiDAR survey. And so we've got lots of room to move around. I also used our live maps to get an image in the background. And you can see here that there is an existing cut block. And there are some existing roads too, which is kind of interesting because I don't want anything selected. Let me just change that. Keep selecting contours. There we go. Yeah, so you can see on the LiDAR there's a road down here, and that makes sense. It's right along the edge of the cut block, and you can see in the image that there's a road going up here, which is completely missing from the LiDAR. So here's a situation where our live maps imagery, which is coming from, in this case, Bing, has got newer data than the LiDAR file. The LiDAR file is missing that road. Right, so I thought we would look at this area here, which still has trees on it, and I'd like to maybe put a landing on top of this little bump. Is that a nice little bump? That one right there? That looks good. It looks like we could get a road in there. Here's how I'm going to do it. Go to our cable analysis ribbon. In the plan window, click on this enable button here. I've got some predefined setups or systems. I'll show you how you create those in a second, but basically it's a yarder combined with a cable configuration. So we've got a slackline yarder in there, which would be a fixed skyline with a carriage running along it. I've got a generic grapple that came with the software, and then I've got another one that I made here recently. And I'm going to pick that one. So it's a grapple yarder running skyline. Various calculations we can do. I'm going to pick the simplest one. We can change that in a minute and see what other calculations are available. And I'm going to make the maximum length of my cable 500 meters, which is bigger than I'm probably going to use. But let's allow it to try out to 500 meters from the landing. And I'm going to do 16 cables at once. We're going to use the auto position checkbox. You'll see what that does in a sec, but essentially it tries different positions and finds the ideal place to put your tail hold. And my tail hold has a height of 5 meters. Okay, I think we're ready to go. I'm going to draw the area as I work, and here's what it looks like. So when I click, it draws in a bunch of prospective cables, and you can see a little polygon is kind of faded into the background there, but it basically joins up the ends of all those cables, and it shows me that that is 24 hectares. And that's what I stuck it right on top of that bump. What if I put it down here? Okay, well, I get good deflection going up to the hill. That kind of makes sense, but off to the side where it's flatter, it's not such good deflection. So you could probe around. Basically, get your plan window so you can see the area of interest. Just click with this new cursor that looks like a 8-pointed asterisk. Click, and it calculates all the possible 16 D-lines branching from that prospective landing, and shows you in plan very quickly whether it's kind of reasonable or not. So there's one in the valley bottom. Here's one on top of a hill. I'm going to go back to this point we originally thought of and anchor it down there. And then I'm going to accept. So the accept button makes them into features. You can see it now in the 3D window. And each one of those features is a D-line. Okay, let's look at this one. So I've selected it as my current feature. Just going to get rid of 3D for a minute and bring up a profile window. And there it is. You can see the profile that we've got. And let me tile this so we can get them side by side. It's got a 7% third point deflection, so basically tower, tail, and then 2 points in between. So we've divided it up into 3 segments. And this one here is almost on the ground. And that's because I had the auto tail hold set. So if I tried to make it go a little further out, it would have hit the ground at that point, and that would be basically not enough deflection. So it's found that point there. If we go to a longer one, let's just set up my profile so that I'm always looking at the current feature. That's also new in version 9. And then I can look at another profile. How about this one? And you can see that that one stretched a lot further. We went out to more than 400 meters here because the ground has a natural deflection in it. This one's interesting. It shows a, oh, that's interesting. The tail hold, yeah, the tail hold is out here, but the loggable area is way back starting there. So it's well, let's play around with that one, see what else we can do with it. Once you've got a draped feature, and all of these are draped features, you can see here in the properties, you can move it around and you can modify its properties. So I've created 16 of these automatically with my Explore button. Now I can start playing around with them individually. What if I just wanted to do one? Well, I could easily just draw a feature with my mouse, but it's also nice to just copy and paste. So if I copy this feature and paste it, I've now duplicated it and I can move it around. Control M for move. Let's move it to another place. And then I can change the, let's see, this is the landing and this is the tail. And you can see the profile adjusting as I do that. So I've just moved it to here. And there's where submarines right there. It's where we hit the ground. What if I pick this up and put it on top of a little hill there? Oh, that looks better. So yeah, one at a time or in groups of, I chose 16, but you can choose any number, 12, 16, something like that. Just to get an idea of the deflection. And now let's go on to the next step, which is to analyze a particular D-line. Let's move that up to there. That's lots of deflection. Sure. This is where you can control what your cable yarder is doing, and it's really very similar to the setup for this thing. You've got to choose a setup, you've got to choose a calculation. All that is available here too. This is where we edit the current feature and any yarder attachments. It's a little bit more detailed than the multiple options, because we're also choosing the landing location, the haulback location, etc. Right, so I can change this. I can say, yeah, don't put it at 500, let's put it at 400. So it looks like that. Oops, what did I do wrong? Let me try that again. Oh yeah, I've changed. 400 doesn't, oh, I see what's happened. I dragged it from up here where it was much longer. And if you set the haulback location to be a big number, it will just use the end of the feature. So it's not going to actually move until I get something less than, what is it here, about 275 or something. Anyway, if I set that to 200, that's what it looks like. Similarly, I can change the calculation parameters. So maybe I'm interested, this is a grapple yarder, maybe I'm interested in how high I can lift a load of 30,000 pounds. You can change the units there if you want. Okay, so this is a different calculation, and it now looks like that. Oh, that's not very good. It's not able to lift it at all, probably because of the setup here. And let's just reduce the number of pounds to 20,000. Okay. Great. Okay. So as you can see, there's some spots where it can't lift 20,000 pounds above the ground. What else could we do? We could use this button here. How far can I yard 20,000 pounds and still get ground clearance? Zero clearance. 263. Oh, actually, it's better to move my tail out, not in, because of the nice deflection on the ground there. Now that turned out, I'm guessing there's some sampling issues here, because you can see it did actually go underground here a little bit. But if we wanted to make sure that it wasn't underground, we could do that again with a slightly bigger clearance. So let's say 2 meters clearance. Okay, AutoCalc. Oh, and now it is way shorter. down there to get that 2 meters clearance. So you can play what if scenarios. You can try different things. I'm going to put that back to 0 because it's going to confuse me later. Yeah, what if I try to higher spar? Let's put a 10-meter spar at the end and see where it goes. Okay, it goes right to the end of the feature, like so. Different yarders can be quickly tried. So we've been working so far with this grapple yarder. Let's put in a slackline yarder. So I set up this yarder earlier. It has a 30-meter tower height, which is higher than my other one. And skyline with butt rigging, I could have configured it differently, but that's how I set this one up. It now has 2 haulback locations because the skyline and the haulback can go in different locations. Generally, we just use the same one. And I'll click OK here, and you can see it instantly updates and does a different calculation for you. Now, a skyline, you can, well, let's look at the calculation parameters for a skyline. Minimum deflection given load doesn't really make sense when you've got a fixed skyline, because in this calculation, it's lifting and lowering the yarder or the grapple or the carriage, whatever it is. However, this kind of makes sense. I want to lift a certain distance from the ground. Let's pick a number here. And how much load can I lift if I winch up my carriage to that height? What's it going to, what kind of load will it lift? So there's the carriage path, 5 meters above the ground, but I'm not seeing any interesting information here about load and cable tensions and things like that. So the profile window has options here under sub-windows, and this is only available if you've got the cable analysis module, to add all kinds of different things to the sub-window. So for example, the tensions legend, load, errors maybe. There. Okay, what does that look like? So we've got a bunch of information displayed. Here's the load. If I lengthened and loosened my carriage so that my skyline, so that my carriage was just skimming the ground by 5 meters, this is the load I could lift at each point. So what I would probably do is say, okay, yeah, I can lift lots of load near the main line, but probably here's the kind of load I want to get. And the deflection for that, oh, I didn't display deflection. Let's turn that on. And the deflection at that point, now this is using a graph, so it's kind of hard to read. Why don't I use a table? And you can do that as well. There's a window called the D-line data table. Where the heck is it? There it is. And you can add various items to that. Now, you've probably seen options in other places in our software for doing this kind of thing. Like here's the load. Here's the tensions. Now I've got some information in there. And if you've used our software before, you know that those kinds of settings, like cable data options and plan window options and profile window options, all those settings can be saved in screen layouts. So I'm just going to shortcut here and open a screen layout that I prepared for doing this analysis. There we go. So I've got the plan window showing my yarder. This is the one that I'm working on right now. You can see the cursor moving in the profile window. And I've got data information down here in my cable data window. Right, so what I was just about to say is that probably this point is kind of interesting, or maybe this point here. That is at station, what, 200 something? So out, oh, 250. Oh, sorry. Yeah, that is about 200. Yeah, so around here somewhere is my, yeah, 3,100, 31,000. That's a reasonable load that'll give me, I'll be able to have clearance everywhere, and the percent deflection for that is 11%. Okay, so now I'll do this again. Go into, make sure it's the current feature, go into cable analysis, edit, change the analysis to lock down my deflection. Fixed skyline, this is it, yeah. So 31,000. What did I say, 11? 11 or 12, let's say 12. 12% deflection. So different calculation parameters. That's what my carriage path is going to look like when I'm hauling that constant load of 31,000 with a constant deflection. Or if you're willing to work with simple approximations, you can always just use the simple, the simple third point deflection, which is pretty close to the same shape. Just pick the deflection number, reflection percentage, and there's your display. Of course, with simple third point deflection, it's not really doing any calculations. It's just drawing you a picture. So most of the stuff we were looking at before is blank. Okay, so lastly, I wanted to show you the things that you actually do first, which is to set up equipment and logging setups. So equipment is just a list of yarders, and you need to know some technical details about the yarder, but not a whole lot. So let's look at this one, for example. To set up a yarder, you need to know the tower height, and you will have to convert to feet. This is the only place in the software where you can't use meters. Everything else you can set up however you like, but you do need, for a well-defined piece of yarding equipment, you need a name, you need skyline, mainline, and haulback, maximum working tensions, and weight per length. The actual length of the cable drums is not important. Those are just for reference. You put those numbers in to remind you how far you can go with the yarder. But these 6 here are very important. Now, if you're dealing with a grapple yarder, actually that was being used as a grapple yarder too. It doesn't use the. Let's just look at that again. One of these doesn't get used. Yeah, the skyline. For a grapple yarder, for a running skyline, the main line and the haulback are the only cables that get used. The third drum for the skyline is not used. So it's okay to leave those blank or put in dummy numbers. Right, now a yarder can be used with different cable configurations, and that's what a logging system is all about. So for example, this one has in it a yarder. So there's all my yarders. So I have to pick one of those, and then a cable configuration. So running skyline with grapple, fairly typical around here. You can also use skyline. That's a fixed cable, and then the main line and the haulback are separate. These things have pictures. They're not great, but they do kind of give you an idea. So if I click on that, the picture changes. And these setups have no configuration to them. They're hard-coded into the software. I think we've got them all, and you should be able to find whatever you're using in here. So like I said, the ones that are pretty common are skyline, either with a special carriage or just butt rigging, or even with a skyline with butt rigging and mainline. That's just a downhill yarder. There's no haulback. So there's a few different options here. In addition to the machine and the cable configuration, you can also put in a carriage weight, which might vary from system to system. So that just defines a list of systems, and then whenever you want to do an analysis, you select the feature. Let's say we got a feature with nothing on it, so I'll just draw a new feature. So here we go. I'm going to create a new draped feature. And I'll draw it with my mouse. I'll do it from here to here and set up my window here to show the current feature. There we are. There's my profile. If I want to analyze that, I just need to go into cable analysis and click new, and then pick whichever yarder I want and set up all the rest of it. Usually the landing will be at the beginning, the haulback will be at the end, but you can use this AutoCalc thing to find a position once you've picked your calculation type. So there it is. Finally, I want to show you a multi-plot. So we've been looking at one profile at a time, and because I've set this profile up to automatically show me the current feature, I can quickly move around my existing D-lines and look at them. And this is kind of good for when you're just setting things up. But if you wanted to print something out, you might want to put more than one on a page. And why is my plan window showing those nasty fat cables? Interesting. Huh. That's controlled here, and it does show only 1 meter there. There's something strange about, oh, I think it's been zoomed in or something. Let me just, oh, it's the scale's locked. Okay, unlock the scale. That's better. Yeah, okay. So my screen layout had the scale locked. That was an oversight. Probably something I should fix just by rewriting the screen layout, like this one, right? Save, and that'll update it. Okay, let's look at a multi-plot. So I've got a bunch of D-lines on here. I got 2 down there, and I got 16 up here. So it would take a few pages to print it out, but let's look at a multi-plot screen layout. This one does 4 at a time. And there's the top one. I can adjust it to fit. Once I've done that, this is the current feature. You'll notice that they're all the current feature, actually, all the windows. So if I look at this profile here, number 2, there it is. It's also showing the same feature, DL Explorer-2. It's the current one. It's the one that I selected just a second ago, this one. The reason it's set up that way is that when you save a screen layout, it has to be useful for all different projects. You don't know what your D-lines are going to be called or how many there are. So the multi-plot is just set up to show the current one in all the windows. And now I can lock them down. So first of all, let's say that I do want that to be the profile for number 1. So I just go into the options here and turn off auto, and now it's locked in. DL Explorer -2, that's the one that it's going to look at. Okay, then we'll go to profile window number 2. It's still showing the current one. Let's change that. Let's go to this one. Scroll it around so we can see it nicely. Yep, that looks good. And then go into the options and lock in DL Explorer number 1. Now I'm going to preempt a question that has been asked me a couple of times when I've been helping people with support. So now we're looking at profile number 3, right? Oh, that's 4. Where's 3? There's 3. Okay. It's way off the screen. Zoom extents. There it is. Okay. And that's DL Explorer 0. And I'm going to lock that one down too. So the question is, how do I label these things correctly? And the answer, what went wrong with number 1? That's weird. I must have moved it around somehow. The answer is you kind of have to do it manually. So there's a little rectangle that allows me to enter in any text I want. And so I'm calling it DL1. But basically I can put any text there I like. And the reason for that is that there's no label either in the sub-window or in the profile that automatically displays the name of the feature. It's kind of an oversight on our part, and we're looking into to adding another label class, or maybe maybe an automatic label in the multi-plot. Haven't really thought it through. But to tag these things, that's probably the way you're going to do it in the near future, is make sure that your multi-plot screen layout has a rectangle. And I'm not going into the details of multi-plot, but basically you can create rectangles here that has the correct label in it. Okay, I think that covers the multi-plot. I haven't done the 4th one. Let's just do the 4th one quickly. So here's number 4, zoom extents. There it is. Move around a little bit. Looks good. And lock it down. Oh, I'm still looking at Explorer number 0. That's not what I want. I want this one here, which happens to be called DL Explorer 15. And now that we're looking at 15, which is different, I can lock it in. And now I'm ready to print. So one more thing, if I wanted to make them all line up, I could turn off this auto thing here and put in a nice even number for offset. Whoops, that would be a negative number for offset. If I did that for all of them, they'd all be lined up starting at 0, 50 meters from the edge. Again, now that I've changed this multi-plot screen layout, I don't want to save it as a screen layout anymore. That would be a bad idea, because I've changed the names of each of these to be specific to this design, and it wouldn't work in another design. Same with the elevations and so on. You wouldn't want to have those locked in for another design. Any questions? You can type your questions into the questions area. We have a couple up there already. Question about the accuracy of the LiDAR data. Yeah, you can see in the profile here that the ground is bumpy, and is there a worry that we're actually getting incorrect information from LiDAR? Well, that's a hard question to answer without looking carefully at the LiDAR data itself. If I were to just look in here at all the points, let's unlock the scale and zoom in and look at all the points, you can see that we've got a pretty dense set of points in there. Let's turn off the image for a sec. So probably my data is accurate. If I was seeing a big hole in the data, then maybe I'd be a little worried about it. The other thing is, when you look at the profile, it really does look nice and smooth. If you were seeing big spikes, you might be picking up some stray points, maybe some foliage points or something, but it does look smooth, so I think it's probably accurate ground data. But if you're not 100% sure and you're worried about that, you can always change the, well, that's up in here, isn't it? Cable analysis, edit, oops. Why am I getting this message? Oh, I've got too many features selected. Yeah, okay, let's just select this one feature, that one. Yeah, so you can change your car clearance here for the auto tail calculation, and you can also change your clearance in the plan window here to show you the green versus red. Like here, we've got it going underground. If I go to plan options, cable analysis, I can change the clearance that goes red. So let's say that we desire 5 meters clearance. And now you can see I got a lot of red spots. Got a question about whether you can export the cable data to Excel, and I don't think you can. Let me just double check on that. So I'm going to the cable data window, which has got nothing in it. Let's put something in there. I'm going to open up my screen layout here. This one had some data in there. Okay, data window. It's selected. You can export it as no, I don't think you can. That's a good thing to add. We do have options for putting the profile into ASCII, which you could bring into your spreadsheet. But and that, if you wanted to actually use something like Skyline Excel analysis program, that's one of the things you would need, is the profile data in an ASCII file, so that you could use it in Skyline Excel. But the data window itself, yeah, that's kind of a boring one, right? Because I've currently got it set up to just do third point deflection.
Excellent, Dave. I think we've got time for one more question here. So last question that we're going to address says, I think you already said that this is a shortcoming, but how can I reference my D-lines to the map? And is there a simple way to indicate where each of those profiles is located?
Sure. Okay, so if I'm looking at, whoops, let's unlock the scale there. If I'm looking, now I've got the multiplot gone, but yeah, this profile window here is that one there. It's the current one, and you can always display in the plan window all the feature names. So that's totally doable. If I display the labels and turn on, well, I don't want to turn on the labels for all features. That would be a disaster. Let me just select only the D-lines themselves. So I just selected those 16 features that are D-lines, and then I can turn on labels in the plan window. Whoops. Modify selected labels for selected feature labels. That's what I want to turn on. Not all labels, just the labels for the selected features. And yes. So there's the feature name right there. And there they are. So that's fine for the plan view. For the profile view, like I said, the only way you can do it is to make a label. If I turn on, let's see, labels, floating labels. There we are. Floating labels is already turned on. Good. If I turn on floating labels in the profile window, I can actually label each window like this too. That's a completely different way to do it, but maybe better. Go into label edit, click with the mouse, and type in your label. So let's call this D-line 5. I don't know if it is D-line 5 or not, but I'll use that. Let's make the font way bigger. And then you can move it around. You can rotate it. And that line that you see there underneath, I think that disappears as soon as I go out of label edit mode. There we go. So that would appear in my multi-plot as long as that part of the screen was there. I think maybe that's a nicer solution. But again, it does require you to type it in because the profile doesn't have any options for displaying the current feature. It's up in the title block here, right? There's the feature name. And so we never bothered to put it in as a label. Well, I guess that's it for today. Thank you very much for your patience and attention. This will be available in our YouTube videos, and you'll be receiving an email with that link.
Awesome. Have a great day, everyone, and thanks, Dave, for the presentation.
Bye now.